And now, introducing F.IF.7.a, graphing linear equations. Now, if that doesn't get you fired up and ready to go today, I don't know what does. This is graphing linear equations using the idea of functions. Um, I chose this standard. I actually could have chosen a couple of standards. I had a look or an eye on CED 10 at the same time, but I was talking with the math department, as I always do, and we decided that maybe this one would best fit today's lessons, and I have a couple more videos coming when it comes to graphing these linear functions. Okay, what I want you to ignore in the standard, though, is anything that says quadratic, minima, maxima. That deals with something we're going to do later on at the end of the year, so we'll just underline what we're talking about. We're going to be graphing linear functions, not quadratic yet, and we're not going to be dealing with maxima and minima. Couple terms to know. Please put these in your binders. All right, we're going to be graphing this equation, y minus 2x equals 5. One of the main points of this lesson, they talk about this thing called standard form. And standard form is ax plus by equaling c, where a, b, and c are all integers, and a and b cannot both be 0 at the same time. If you put zeros in for a and b at the same time, anytime you multiply by 0, you're going to eliminate those terms. And if you eliminate both x and y, you're not going to have any ordered pairs to plot on your grid. So what we need to do is take this equation, create a function table, which we've already learned. We know how to create a function table. I'll go with the vertical variety. And since they didn't tell us what domain, they did not define a domain for us, they didn't tell us what x values to use, we're going to make them up. So let's just take some values, I don't know, x, such that they fall between, let's just go between -2 and +1. Now, between means I can just have these inequality symbols, but let's say I want to use those two numbers. I'm going to put an equal sign to include those numbers in our function table. So that means x is going to be equal to -2 and greater than -2, all the way up to and including +1. Now that gets us half of our values. In order to get the other half of the values, our other half of our coordinate pairs, or our y coordinates in the ordered pair, we're going to use our equation to help us find that. So let's take our equation. We're going to substitute in the x, the value that we chose. So in the equation x, let's substitute -2 for that. So -2 times -2, and that is supposed to be equal to 5. All right, do your math. That gets you +4. So y is going to equal 1. All right, so when your input is -2, your output is +1, and that has generated one of the ordered pairs on this line. Now let's choose another one. The next one is -1. So y minus 2 times our given domain is equal to 5. So y is equal to 3. So when our input is -1, our output is +3. And let's pick a third one just in case. We know that two ordered pairs can make a line if we have a straight edge or a ruler to draw it. Just in case we didn't make a mathematical error, we want to make sure that, the third and the fourth, and maybe even sometimes the fifth and sixth ordered pairs, they should all be on the same line if we did it correctly. So let's just take that 0. So y minus 2 times the domain, 0, is equal to 5. So y must be equal to 5. Okay, so when your input is 0. Your output is 5. All right, now the task. Now that we have 3 pretty solid mathematical representations on this line, let's go check it on a grid. So our first ordered pair is -2, 1. Our second ordered pair is -1, 3. They look like they're in a line, right? I could take any straight edge and just draw a line there. But let's make sure that our third point, our checkpoint, is going to fall in line with those two. That was 0, 5. So we go 0, 1, 2, 3, 4, 5. And they do. So let's get out our ruler, draw a nice straight line here. And let's capture the bottom part of this too, if we can. All right, so I lost it a little bit there. Okay. And that'll do it. So if we wanted to label it, we know that the equation was what? Y minus 2x equals 5. Come over to the line. Y minus 2x is equal to 5. Okay, second problem. Thinking about the standard form, what happened here? We don't have an x value, so it looks like the coefficient of the x was a 0, so that kind of eliminated the x, and we were left with by equaling c. And the coefficient b is known as the coefficient in front here, which is a 1, so it's saying 1y is equal to 1. And what is that going to look like on a grid? All right, function table. We don't have a defined domain, so we get to make it up. Choose some easy values. How about any x value that is less than or equal to, let's just stick with it, less than or equal to 1 and greater than or equal to -2. All right, -2, -1, 0, and 1. And then we don't even have to do any math equations here because it says right in the equation, y is always going to be equal to 1. So y is 1, y is 1, y is 1, and y is 1. And now we go graph that. So -2, 1, -1, 1, 0, 1, and I could just keep going. 1, 1, 2, 1, 3, 1. And it looks like we have a horizontal line that is running parallel to the x-axis. And you can do the same thing. If the problem was reversed and it said x, let's just say x is equal to, I don't know, make it up, x is equal to 5, that means in my table, they define the domain for me as always being 5, and then, you know, you get to make up your range value, whatever you want it to be. I'll just choose a couple values, 0, 1, and 2, and that is going to graph out at 1, 2, 3, 4, 5, a vertical line that's running parallel to the y-axis. So it's kind of opposite. Okay, last problem. Y is equal to 2x plus 3, and they gave us a defined domain. So -4 all the way to 0. Now that's a lot of values. You know, according to the directions, if they want you to fill in the function table for all 5 of these values, go ahead and do that. But you know, you could check 3 or 4, and if the math is right, then the dots should all be lining up in a straight line. They're all solutions. All these ordered pairs are called solutions to the linear function. All right, so let's just take 3 of these things real quick. -4, so y is equal to 2. Plug in my given domain, plus 3. All right, so our first value is -5. Let's go with a second one. All right, so when my input is -3, my output is also -3. And let's do one more. Let's take that 0. 0 is easy to work with. All right, so when my input is 0, my output is 3. So let's go graph all these 3 solutions. See what our graph looks like. -4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. -3, -3. And then the last one, oops, sorry. 0, 3. So 0, 1, 2, 3. Now they're a little further away from each other. That's okay. We would have a straight edge or a ruler, whatever you use, that edge of a textbook, and create this line. All right, that'll do it. In your journals, define the given terms that I gave you on page 2 of the flip chart. And if you have any questions, please write those down. You can bring them to class and write a couple things that maybe you learned, maybe something new that you came across today that you didn't know before.